We'll continue the third chapter, that is machines. We'll see the difference between ideal and practical. Ideal, the efficiency is 100%, and in practical it is always less than 100%. Ideal machine, it is weightless, elastic and perfectly smooth. Practical, it is not weightless, it is not elastic or perfectly smooth. Ideal machine, there is no loss of energy, hence the efficiency is 100%. And practical, it is it has few, you can say there is a loss of energy due to friction, and hence there is always, the output is always less than the input, whereas in ideal the output is equal to the input. Clear? So this is the difference. But no machine is ideal in real sense. All the machines are practical, or you can say the efficiency is less than 100%. Next, we'll see few of the numericals. Okay, don't see the number, you can just see the question. A crowbar of length 120 centimeter. Now crowbar is just like Nike sign, okay, has its fulcrum situated at a distance 20 from its load. Calculate the mechanical advantage of the crowbar. So it says that it has a mechanical advantage. So the total length is 120 centimeter. Its load arm will be 20. How did you come to know the load arm is 20? Because if you check, it's written that the distance of the fulcrum from the load, and the distance is always from the fulcrum. So load arm is 20. If load arm is 20, total is 120. So its effort arm will be 120 minus 20, that is 100. So you have effort arm, you have load arm. You have been asked to find the MA. Now ideally your MA should be equal to VR. Ideally means what? Efficiency is 100%. So instead of MA formula, I can say MA is equal to VR. We will use VR ka formula. VR formula is, it is DE, that is effort arm upon load arm. So 100 centimeter upon 20 is nothing but 5. No unit. MA does not have any unit. Clear? Next, a pair of scissors has its blade 15 centimeter long while its handles are 7.5 centimeter. Now pair of scissors have blades. So imagine you have a pair of scissors, center is the fulcrum. At one end you have, say, load, that is paper or cloth. On the other hand you have the handles. So the end where you have the handle, so you are applying the effort, so that is the effort arm. Paper or cloth, it is the load arm. So here it says blade is 50 centimeter, so the load arm is 15 centimeter. Handles are 7.5. Means what? The effort arm is 7.5. Find the MA. MA's formula is effort arm upon load arm. So 7.5 upon 15, answer is half, that is 0.5, no unit. This answer is correct. How did you come to know it is correct? MA is less than 1. If MA is less than 1, it is used as a speed multiplier. And you know that the scissors are speed multipliers. So your answer is correct. Next question. A force of 5 kgf is required to cut a metal sheet. A shears used for cutting the metal sheets has a blades 5 centimeter long while its handles is 10 centimeter long. What effort is needed to cut the sheet? The force of 5 kgf is required to cut the sheet. So the load given is 5 kgf. Blades are 5 centimeter. Now you know that if you want to cut metal, it is not easy. So you have to use a machine which has MA greater than 1. Means it has to be a force multiplier. So the blades are 5 centimeter. So that is what load arm. Handle is 10 centimeter. Handle 10 centimeter means what? It is the effort arm. What effort is needed? So if you check what all things are given, load arm is given, effort arm is given, load is given, effort is asked. So I will use the formula effort into effort arm is load into load arm. That formula I can use it. So I will get 5 into 5 is 10 into x. 5 kgf, that is the load, into load arm. So 5 into 5 is 25. that is equal to 10 into x. So I will get x as 25 by 10, that is 2.5. What will be the unit of effort? See here, effort arm and load arm both are in centimeters, so they will get cancelled. Your load is in kgf, so effort should also be in kgf. So the answer is 2.5 kgf. And how can you be sure that your answer is right? See, you had a load of 5 kgf, but you are applying the effort only of 2.5. So it is pretty clear that you are applying less effort, means you are applying less force. So the machine has multiplied your force. So it is a force multiplier. Clear? Next. A man uses a crowbar of length 1.5 centimeter to raise a load of 75 kgf by putting a sharp edge below the bar at a distance 1 meter from his hand. Draw the diagram of the arrangement showing the fulcrum, load, effort with their direction. State the kind of lever, calculate load arm, effort arm, MA and the effort needed. So crowbar is class 1. So you can see the crowbar just like a Nike sign. At the top you are using the effort, bottom you have the load, and the center you have the fulcrum. So fulcrum is at the center, it is class 1. The whole length is 1.5, load of 75 kgf. So the load is 75 kgf. See the unit. By putting a sharp edge below the bar, so edge is nothing but the fulcrum, 1 meter from his hand. Hand means the effort. So the effort is 1 meter. The whole length is 1.5. Effort is 1. So the load arm will be 1.5 minus 1. That is how much? 0.5. So you have effort arm, you have load arm, you have the load. Can you find the effort? Of course you can find. You can use the formula. Load into load arm is effort into effort arm. That is one method. Second method is you can find MA and equate that to VR. Because it is nothing is given, so we have to assume that it is an ideal machine. Just to revise, efficiency's formula is MA by VR. So if it is 100% efficient, means efficiency is 1. MA is equal to VR. Okay. MA is load by effort. Now here the load is given, effort is not given. So I can use the formula of VR. VR is effort arm upon load arm. You have already found it. Effort arm is 1, load arm is 0.5, answer is 2. Now you know that MA's other formula is load by effort. MA is 2, load is 75 upon effort. So if you want effort, it will be load upon 2. That will be 75 by 2, which will be 37.5. Unit will remain the same, that is kgf. Whatever is the unit of load will be the unit of effort. Clear? Next sum. A lever of length 9 cm has its load arm 5 cm long and effort arm 9 cm long. Now here you have to be very careful. The lever is 9 cm, load is 5 cm, even the effort is 9 cm. So the effort arm is equal to the whole lever, means the fulcrum should be at one end. So you can see the diagram, fulcrum, that is the blue color, it is at one end. Load is 5 cm from the fulcrum. To which class does it belong? Load is at the center. If load is at the center, it is class 2. Find the MA. MA is equal to VR, so effort arm upon load arm. That is 9 by 5, answer is 1.8. Very easy. What will be the MA and efficiency? Okay, you have to find VR also. If MA is 1.8, your VR is also 1.8. Since in first sub question, they have mentioned that your efficiency is 100%. Second case, what will be the MA and VR if efficiency becomes 50%? Remember one point, if you want, you can you can just note it down. VR will never change. Even if the efficiency changes, VR will not change. Please write it somewhere. If efficiency is 50%, VR does not change. Then what changes is your MA. So, if previously your MA was 1.8, where efficiency was 100. Now, your efficiency is only 50. So, your VR will be half of it. That is 1.8's half is 0.9. Your MA will become 0.9, but your VR will not change. Clear? Next question. The diagram below shows the lever in use. So it is a diagram based question. To which class of lever does it belong? Now you can see at one end you have fulcrum, other end you have the effort, and the center you have the load. So it is class 2. FA is 80. FA, so the load arm is 80. AB is 20, find its MA. Effort arm is always the distance of effort from the fulcrum. In short, you need to find FB. FA is 80, AB is 20, so your FB will be 100. Your MS formula, MA is equal to VR, which is equal to DE by DL, which is 100 by 80. If you divide it, you will get 5 by 4, that is 1.25. Once you have found MA, you know the formula of MA. MA is load by effort. So 1.25 is equal to 5 kgf upon effort. So you arrange the term, you will get 5 upon 1.25, that is equal to 4 kgf. Unit will remain the same. Load and effort will have the same unit. Clear? Next question. The figure shows a wheelbarrow of mass 15 kg carrying a load of 30 kgf with its center of gravity at A. Very important question. Why? The wheelbarrow itself is 15 kg. It carries a load of 30 kg. So if I want to push this wheelbarrow, I will have to take care of this 15 kg as well as 30 kg. So what is the total load present in it? It is 45 kg. 15 plus 30. Clear? Point B in the figure, if you see point B at the bottom and point C are the centers of wheel and tip of the handle. So C is your effort. At point C you are applying the effort, and point B is the fulcrum. You can see there is a small wheel over there, such that the horizontal distance AB is 20, AC is 40. Okay, now see here, load is A. The distance of load from the fulcrum is 20 centimeter, that is AB, and the distance of your effort, that is C, from the fulcrum is 40 plus 20, that is 60. Okay, so what is load arm? Load arm is 20, that is AB. What is the effort arm? That is 60. MA is nothing but VR, so you will get 60 by 20, answer is 3. You need to find the minimum effort required to keep the leg just off the ground. Minimum effort means you have to apply the effort farthest point from the fulcrum, that is from B. So I can use the formula, that is load into load arm is effort into effort arm. Or once you have got the value of MA is load by effort. So your effort will be load by MA. Load is, remember, it is not 30, it is 30 plus 15, that is 45. And your MA is 3. So 45 by 3, you will get the answer as 15. Answer is 15 kgf. Next question. This is from the next exercise. A woman draws water from a well using a fixed pulley. The mass of bucket and the water together is 8 kg. The force applied by the woman is 70 Newton. Calculate the mechanical advantage. Take G as 10. A woman draws a water from a well using a fixed pulley. So fixed pulley means you know that MA is equal to 1. Mass of the bucket and the water is 6 kg. The force applied by the woman. Now the force applied is nothing but the effort. It is 70 Newton. So the effort is 70 Newton and the load is in kg. So first thing is you need to convert kg into Newton. How to do that? You will multiply by 10 because weight is equal to mg. So 6 into 10 will be 60. Load is given, effort is given. Can you find MA? Yes, MA is equal to load upon effort. So 60 upon 70, if you do 0 cut, you will get 0.857. It will not have any unit. Clear?